Hey everyone, welcome to another episode of Munro Live. I'm sure you're wondering where Sandy is. He's out of town this week. He'll be back shortly. So I'm here with Kevin. Kevin is going to help us as we go through an underbody review of the all-new Lightning. So this is a platinum trim level. So top of the line, there are not really any other features that you can get online that this vehicle doesn't have. So she's fully loaded, and we'll start walking through. So Kevin, is there any particular area you want to get started?
Yeah, so obviously as we come underneath the vehicle, it's body on frame, and it is isolated, unlike the Rivian, which is essentially the frame and body are bolted together. So looking at the front of the vehicle and its like front frame module, looks very similar to the ICE counterpart, which is to be expected. I would expect in general, anywhere where like commonality could be brought from the ICE platform to the Lightning, they would do it. It saves on a ton of validation time, development time, and it's probably how essentially they beat almost everyone to market as far as a full-size truck is concerned, leveraging as much as they can with the F-150. So it looks very, very similar looking back. The first thing I noticed that is different is the front Sorb tusk, or small overlap rigid barrier. It is substantially larger in size, and there's some additional forming through here. It is a heavier vehicle, even though it's probably, I don't think we weighed this one yet, but I've been seeing on the internet roughly 500 to like 600 pounds lighter than the Rivian, which is pretty impressive actually, right. Given the size of this vehicle. So there's some probably unique considerations here for Sorb and it being a battery electric vehicle. As we move kind of rearward with the vehicle itself, things look very similar to the ICE counterpart as far as the suspension. It is a short long arm setup. The upper and lower control arms are stamped steel, so there's a ton of volume here. It makes sense for them to use steel. One thing I was kind of impressed with from the previous generation is just how much smaller these lower control arms got. So they have reduced their overall size pretty significantly. So that's something interesting. And then even through the knuckle itself here, you can kind of see some light weighting and some additional like structural features just brought in through the casting itself. So you kind of see some continual improvement. Yeah, thank you. Yeah. So now, as we look down the entire vehicle, you can see essentially the entire vehicle is armored, if you will. This, I would say, is probably somewhere in close to the 3mm range, going almost the entire way down the vehicle itself. And they have essentially an NVH blanket here covering the front of the what appears to be cooling module for the vehicle. So that makes sense as far as trying to keep any NVH transmission out of the cabin itself. And when we come back through here, you can see their front electric drive module. Probably the most interesting thing here is what it says on the side. So it says Van Dyke VEPC. So a quick Google search is Van Dyke Electric Propulsion Center. So it is very likely that this is an internal Ford electric drive module, which is a pretty big deal. I think the Mach-E used an LG front and a Borg-Warner rear, if I remember correctly. I was on that project, forgive me. So, but as we can see, there's some pumps here on the side, a filter for serviceability, and there is a lot of PUR mats around it as well to help again with NVH. Go ahead.
It's curious, maybe before we move any further rearward in the vehicle, just two things I wanted to draw out here. One, Kevin, as you started to point out, the cooling module at the front of the vehicle, it's actually downturned. It may be hard to see via camera, but right through these outlets, you can actually see, the fan, which I'm not going to put my fingers in because this may go into a cooling mode at any time. And then the radiator there. So those look like they're at roughly like a 45 degree angle. And if I had to guess, especially after having looked at the frunk and how much space is up top, that's one of the biggest enablers to getting that big open front end on the frunk, on the front of the vehicle, right? So on the ICE counterparts and just about every other vehicle out there, the cooling module is turned vertical, right? So typically better from an airflow perspective. You've got a lot of other hard monuments rearward of that you want to package for. But here, the frunk cargo space took precedent in terms of packaging. So the cooling module tip rearward. So the Model S does that. Original Humvees do that. Not all for the same reasons, but in this case, it certainly looks like it's for frunk packaging space. So an interesting note there, and we'll dive into that a little bit later as we tear the vehicle apart. And then the other point I wanted to bring up is this right here. So this large monument that I'm kind of wiggling around here is the active air dam. So at a certain speed, whether it's 25 miles an hour, 30 miles an hour, or what have you, these actuators here, there's a stepper motor back there and a rod, probably a worm screwdriver, something like that, is going to bring this thing down. So that's going to improve the aerodynamic characteristics at higher speed, improving the range, so on and so forth. We've seen that on ICE applications. It's not specific to a BEV, but again, clearly they're making an effort to improve range, and you know, between that and the cooling module, there's a lot of packaging effort that went into this.
Yeah, and this whole area before on the ICE truck, specifically the forced induced truck, is where the intercooler cooling module would reside. And then all those pass throughs to the front bumper.
Yeah, for the 3.0 and the 3.5 application before it.
Yes, and 2.7.
Yep.
So the 3.0 is not in production more, the diesel. But, okay. As we start moving, rearward here, this is the worst lift for me. You can kind of see if you want to, like, even on your side, Eric, you want to tuck up and take a look through here. We're seeing a lot of EPDM hoses, quick connects. I mean, it's not unsurprising to us, given what we saw in the Mach-E. Hopefully we can see some more nylon coming in down the line. There's just a lot of weight savings and some packaging enablers there. But again, this truck got into production very quickly. So in some ways, the blessing and the curse of the lightning is it's based off a nice platform, and which helped get it into production fast, but it's also got some constraints there as far as a lot of these hard mounts and how the rails are coming through are all based off of a pre-existing platform. So
we typically say that's like a platform tax, right? If you've got an existing platform with an ICE, how much tax does the other one or the new variant on the block have to pay by nature of being sort of constrained or bounded by ICE monuments within the vehicle that you don't want to change if you don't have to, from a tooling perspective or a engineering design and development ED&D perspective. So it's not uncommon, but we're seeing a few of those cues or things pop out at us as we look under this.
Yeah, look at the pack. This is the extended range, so I believe it's 131 kilowatt hours of usable capacity to the customer. Looks like an extruded aluminum pack, similar to the Mach-E as well, sitting on a extremely substantial stamped steel weldment, carrying the battery, which is also isolated, which is kind of unique. In some ways, it doesn't necessarily surprise me if you see body-on-frame trucks go up on like, what are they called, like RTI ramps or anything like that, and you'll start to see the bodies twist, and specifically on pickup trucks, less so with SUVs, but you'll see the bed and the cab start to come out of alignment. The last probably 20 years of trucks don't do that as much with the fully boxed frames. Specifically on the Fords, they have extremely tall section height with their frames, so they're very, very rigid. But this is the first time we've seen an isolated pack. Is it the last time? I'm not sure. And with how early we're in kind of like this whole EV aspect, we may see more, especially trending on some of these body-on-frame vehicles. But more than likely, there's probably a durability concern overall, or some inputs that are driving some concern for Ford. They want the battery to last. It's an expensive component, and they've spent money to essentially try to isolate it, quite literally, from any potential problems.
Well, and this is a huge pack, right? So it's probably more difficult to pick up on camera, but it's almost from the inside of wheel to inside of wheel, so the full length of the wheelbase just about, and then probably 70% the width of the overall truck. So it's rather substantial. And as Kevin was mentioning, from a structural perspective, there's no shortage of structure. So all of these stamped pieces that you're seeing, all this black steel is what this is, right? They're 2.5, 3 millimeters thick. It's all a giant weldment. And then those isolated points Kevin was pointing out are like right here, right? So this is one of the spots where this bolt's going through, threading into the battery pack, but through a rubber isolator. So from a structural perspective, this ladder frame or this frame to support the battery is actually complementing frame structure and vice versa. So it's adding structure to the frame to help support the battery, and the frame's helping support it. So they're supplementing one another. But I will say, looking at this, so that's the positive. It looks like it's just about bulletproof, and you could run over just about anything you want. That's the good. The downside is it does look like there's some room for optimization, right? So there is a lot of discrete parts in these weldments. There's a lot of welding. I was hoping to see a little bit more of an integrated approach. However, if you're building the first of something, this is the first battery electric vehicle off of an F-Series platform, you'd rather be safe than sorry. And to me, that's kind of what I'm seeing. There's a relatively short development cycle from what I understand. And with that, you get some things that may not be the most elegant and optimized, but I would be willing to bet this is extremely functional.
Yeah. And one thing I'd like to add to that, Jordan, is, I think initially the volume forecast was they were going to do, was it 50 or 70,000 units?
I think it was closer to 50 initially.
50, and then they essentially tripled that volume with hoping to get to the 150,000 units a year next summer, roughly, based on their recent commentary when it launched. That's an important note. Obviously, as you go through all this, you're making decisions based off of volume and tooling and all these things. They all matter. And as the volume kicks up, and if they decide to increase volume further in the future, I wouldn't be surprised to see on like a mid-cycle action significant kind of changes being brought into this platform. And Eric, you could probably get it from here. One thing I just want to highlight before we go any further rearward in the vehicle is just you see the space here, the battery pack to the frame, and I would say there's roughly probably 25 to 30 millimeters of clearance there. And then as we move outward, you see the edge of the frame and then the body. So this is one of those taxes, if you will, that Jordan was mentioning that you pay for an existing platform. So this cab is common with the F-150. Really on a regular truck, you're just packaging a fuel tank, a drive shaft, an exhaust system. It doesn't need a lot. It doesn't necessarily need the frame to kick out all the way to the rockers here. I would imagine in maybe a next iteration of this, we could see them try to use and package the space, bring the frame out if it stays body on frame, and then put in a bigger pack going down the line.
Now, if I put my impact hat on, though, from a side pull perspective, I want as much space there as I can possibly get. So again, as we're talking about in a development process, going quickly, being relatively conservative in some regards, impact is not an area where you want to take extra risk on. So to me, for sure, there's the commonality to an ICE, but then the other thing I see is that, right, they want to make sure that they're not going to have any major concerns from a side impact perspective. So, and that distance from the outside of vehicle or the sill section to the first point of contact on the inside of the battery pack, the space there, the structure there, the void there, right? Like where you don't, we call it free crush space, how all that layers together is extremely important in your impact script, right? So as you go up in weight, the focal point on that grows.
No, absolutely. One thing I guess I'm not surprised to see the steel skid plates, but we've often used, Ford's polymer skid plates as an example on their fuel tank, specifically on some of their more off-road focused variants, like the Raptor, the new Bronco has it. I was kind of expecting to see some composite skid plates under here. I understand why they may not pursue it per se, because steel is easy to protect as far as both forming and for protection. But it is relatively light as is, but I can see, some more weight eventually being pulled out. I don't know what type of internal requirements are driving maybe the thicknesses of these, or even just the material itself.
Yeah, we've seen people go, roughly a square inch, a point load, in some cases a quarter, and sometimes half GVWR, so gross vehicle weight rating, and a singular point. So, you may be like, well, it doesn't need to be that thick, but when you take, 6,000 pounds plus, or half of that over a square inch, that's a lot of energy to manage. Mm-hmm. Yep.
But I don't know, there's definitely some, I think, optimization in the future. I would have liked to have seen, they have these kind of horn features coming out. There's, 1, 2, 3, 4. There's a series of separate pieces here. They do use hydroforming. I think you could do one single piece coming across. These longitudinal members could be a single hydroform piece with these cross members going across and welded together. But yeah, it's interesting for sure.
And maybe the last point before we move to the rear suspension is just looking at these shields. So instead of taking these shields, so these rectangular cutouts, and welding them in, they did choose to use threaded fasteners here. So typically we say, you know, let's get rid of fasteners. I'd rather see it be an integral unit. However, I suspect they probably did this from a serviceability perspective. If one of these gets damaged and or for some reason you want to get above it, instead of dropping and trying to replace or cut out a shield and bolt in a new frame, here you can just locally replace one of those sections or those shield sections. So I'm sure that was probably a deliberate choice as they looked at this. But what do you think? Let's take a look, or I'll look at the rear, Kevin.
Yeah. So as we come back, you know, initially when you started seeing like kind of spy pictures and things of that of a lot of, you know, the F-150 Lightning prototypes, actually, I think a lot of the early ones were actually confused for Rivians because they were using Fords as test bodies. But I was kind of surprised to see that it didn't use essentially like a multi-link similar to what the Expedition uses. But when you look at this from probably a durability and just even simplicity standpoint, they're using extremely large cast trailing arm assembly for this with an integrated knuckle. Kind of reminds me of the Ford Escape. That's a stamped kind of twist beam setup. But again, it's cheap, it's very efficient from that perspective, and it probably provides a great balance between, you know, ride quality and durability over a multi-link rear. And I don't know if you'll see it in the ICE versions coming down the road, but it's probably one of the most major departures in the F-Series lineup for Ford, and besides obviously the fact that it's an electric vehicle. But as far as its suspension architecture, would be an independent, you know, rear.
Yep. And then as we move rearward, looking at the primary or the rear drive unit, so this is probably, if you look at a power split, this is going to provide a larger percentage of the power in terms of vehicle traction. It does look like they've got a coaxial setup, so they probably have, just based on the packaging, right, looking at how inline essentially the center of the entire module is in line with the half shafts right here coming through the center line. So probably is coaxial, probably a planetary set or something like that. We'll tear that down shortly. So not terrible on the packaging, shielded pretty well. And it doesn't seem to be giving them any major grief in terms of the functional package of the spare, the frame, and then obviously above it, if you can tuck in here, Eric, it looks like the inverter and probably, so the inverter for the motor and then probably some of the other high voltage modules we're seeing there may be for the Power Pro system at the tail end of the vehicle, so we'll take a look at that. The only thing that I was hoping to see on this vehicle that I'm not is an integrated inverter. So what I mean by that is on this vehicle, we've got a separate drive module and a separate inverter. So that means that you have to have a discrete coolant loop going to the motor, separate coolant loop going to the inverter. Same with the high voltage connections. We've seen other people integrate those two to save on the fasteners, the jumper lines, all the above. So they may trigger something like that in the next go around, but nonetheless, they were still able to package what they needed to, and they made it into production.
No, I mean, it's arguably probably, in terms of like its impact, I would say on the auto industry, it's pretty substantial. You know, the Rivian kind of beat it to market, but it's like a mid-size, more niche vehicle itself. But the bed is common, you know, grossly speaking, with the ICE version. The cab is also common. So all of your accessories that fit on an F-150, your ladder racks, your rooftop tent stuff, anything like that will fit in this. And then from like a commercial perspective, you know, salt spreaders, if you were to use it, I think that's kind of one of the key attributes to this truck in comparison to any other current electric truck on the market, or even like near future, is from a working perspective and like the mileage gains and the emissions that you save on, like, especially like on the industrial side, is huge with this particular vehicle, because it can take essentially the industry standard accessories for the bed, which is kind of interesting to me, in general, and why I think it's a pretty big deal, like in general, for the automotive industry. The EV Silverado is essentially a top-headed Hummer, with a midgate. It's interesting, it's cool, but this has a lot of versatility, and it's going to be kind of interesting to see what kind of splash it makes, like in the market itself.
Yep. So, well, we're going to be dropping the rolling chassis shortly. We're going to get the high voltage battery pack out. We'll take another look at when the vehicle is actually out on the ground, so we can see a lot of the components that we were talking about from the top side, and get a better look at how those things are packaged. So we're excited to get there. And all in all, good execution. There's some areas that we're seeing for some more optimization that could take place in maybe a mid-cycle action format or something like that. But all in all, it's pretty cool. We can't wait to dig in.
Yeah, no, I'm pretty excited. I was very excited about the Rivian. That's a very interesting vehicle to me personally, and then this is kind of the next one on the list. So yeah, I'm excited to kind of get into it for sure. Especially the motors. That's a big. If these are being built by Ford, that's a big step, forward. You're a real car company if you don't build your own motors. So.
Sure. Well, on that note, thank you all for watching. Corey would have me ask you to go ahead and hit that subscribe button. So if you would, go ahead and hit that if you're feeling like it. So thank you again. We'll join you soon for the next video. Appreciate it.